Hello everyone, so welcome to my new video. So in this video we are going to learn about special algebraic tricks. Now why is that? Well, look at the function that you have to integrate here. Now here's my question for you. Think about a rule from rule 1 to 10 that we learn in this lecture series. Think about a rule that you can use here right away. Think about one. Can we use like x, if you want to integrate x square, it's x 2 plus 1 over 2 plus 1? Not really, right? Can we use natural log rule, like you have x here, so it's like 1 over x? Or can we integrate it like this? Oh, this is 1 over x times x square plus 3. So why don't we just integrate 1 over x, it's natural log x, and then integrate this one, then multiply? Can we do that? Well, no, we can't do that. We didn't learn an integration property when we have a multiplication of two functions, right? So that is why you need algebraic tricks or integration by substitution or parts or partial fraction, all kind of techniques to integrate some functions. Now we are going to discuss this in broad sense in one of our future videos, but for now let's learn whether we have some algebraic tricks so that we can simplify that function and get something that we can integrate according to our rules. That's the goal. So that's the question that you should ask first. Look at the function that you have to integrate. Think about whether I can use an algebraic rule. Can I simplify this function furthermore? Okay, if you can, please do it. If you can't, then you need a different technique like I explained you before. Okay, how can we simplify this function? One of the tricks that often comes up is look at the denominator. It's so simple, right? Just a single term, just x. Well, our numerator on the other hand is two terms, or you can have 3, 4, but longer than the denominator, right? Okay, in terms of number of terms, what I can do is let me divide each term in the numerator by denominator, or I split this fraction. How can I do that? I can write it as x square over x plus 3 over x. Okay, and then of course dx. Now x square over x is x, right, plus 3 over x. This is what I get when I simplify. Now can I integrate this new function? Of course yes, because I can integrate x separately and 3 over x separately, and then you can add, because we learn the integration property when you have addition, right? If you have forgotten that, or if you have not learned that, please click on the link appears above to watch and learn it again. So what do you get if you integrate x? You get x square over 2. What do you get if you integrate 3 over x? It's 3 times natural log absolute value of x plus arbitrary constancy. So this is what you get after you integrate that function. So that is a famous algebraic trick where you split the fraction. But you have to be careful. Don't do that if your denominator is a little bit complicated. I will show you examples when not to do it. How about 1? Oh, it's look like a mess, right? But look at the numerator, it's big versus the denominator. So let's split it out. So x square over 2. So let me do it slowly. Okay, 3x over x plus square root of x over x. Okay. Alright, so x square over x is x. 3x over x is 3. X cancel out. Plus square root of x over square root of x. What is that? 1 square root cancel out, right? So you get 1 over square root of x. Now let's integrate. Okay, so if you integrate x, what do you get? We get x square over 2. If you integrate 3, you get 3x. If you integrate 1 over square root of x, well, we can write 1 over square root of x as 1 over x to the half. 1 over x to the half is same as x to the negative half. So you switch the sign of the power when you take it to the numerator. My bad, from denominator to numerator. Now let's so integrating 1 over square root of x is same as integrating x to the negative half. So what do you get if you integrate x to the negative half? X to the negative half plus 1 over negative half plus 1. If you don't know how to integrate a square root, watch the link on the link that appears above the video to learn that. And of course plus c. Okay, so let's see what we get. We get x square over 2 plus 3x. Negative half plus 1 is half. Over negative half plus 1 is half. So this dividing by half, I can write it as reciprocal multiplication. So reciprocal of half is 2. So let's multiply by 2. Let's have 2 here plus c. This is what you get. Okay, so that's the algebraic trick. Okay, right. Question 2. Okay, now 2 looks different because we have 2 terms, but still give it a try. Give it a try. If you give it a try, you get x cube over x plus 5 plus 2x over x plus 5 plus 6 over x plus 5. So can you integrate this one now? Did it simplify your integral? No, right? I don't know yet how to integrate x cube over x plus 5. At least we don't have a rule yet because of that x cube. Well, we know how to integrate 6 over x plus 5. Yes, we know that. It's 6 times natural log x plus 5 after you integrate. But still we don't know how to integrate 2x over x plus 5 using a basic rule, right? So no, this trick is not useful here. Alright, so that is how you determine. So we don't know how to integrate this one yet. Same here, question 4. Okay, 4, if you use that rule, it's 3x over x square plus 25 minus 6 over x square plus 25. Can we use the help? No, we know how to integrate this one using tangent inverse in the previous video, right? But no, we don't know how to integrate that yet. It didn't help. Okay, all right. Now let's look at question 3. Let's do question 3. Okay, so we have 3x square. So let's divide each term by square root of x. So then you have to integrate 3x square over square root of x. So this requires little bit of work. Okay, so let's see. Now here, alright, so let's write the square root of x as the power of half because it will help us. 3x square x to the half minus 2x over square root of x. One square root cancel, right? X is square root of x times square root of x. So one square root cancel. So I can write it that way. So this is 1 over x to the half. But I can take that x to the half to the numerator and write x to the negative half. Right? So I did that. Well, how can I simplify this one? Same way. Take x to the half to the numerator. So then it's 3x square times x to the negative half. How can you simplify these two? So you have base is same. Base of these two terms are x. Power is 2 and negative half. So when you have multiplication of these two terms, you can add 2 and negative half. That's a power rule, right? So add 2 plus negative half is actually 3 half, right? So if you simplify, you get x to the 3 half. So you have to master those skills definitely before you take calculus 2 or any mathematics course that is higher than calculus 2. Okay, if you don't know it, please take your time, review your power rules and do the problem again. Okay, now we can integrate. So let's integrate. Here, if you integrate x to the 3 over 2, it's 3 times x to the 3 over 2 plus 1 over 3 over 2 plus 1. Okay. Here, 2 square root of x is same as 2x to the half. So if you integrate 2x to the half, half plus 1 over half plus 1. Plus, if you integrate x to the negative half, you get negative half plus 1 over negative half plus 1 plus arbitrary constant c. Okay, all right. So now we can simplify this furthermore. 3 over 2 plus 1 is actually 5 over 2. X 5 over 2 divide by 5 over 2, so that I can use reciprocal multiplication. So it's 3 times 2 over 5 minus here 3 over 2. So 2x 3 over 2 divide by 3 over 2, I can use reciprocal multiplication there. So it's 2 over 3. Plus here negative half plus 1 is half, so x half. divide by half, I can use reciprocal multiplication. Reciprocal of half is 2. So here 3 times 2 is 6. 6x 5 over 2 over 5 minus 2 times 2 is 4x 3 over 2 over 3 plus 2x to the half plus c. Phew, okay, that was a big problem, right? Yes, it was. Okay, so now this is how you integrate that type of a function. Okay, so lots of algebraic tricks, power rules, divide each term by fraction, and reciprocal multiplication. Everything is super important in calculus 2. Okay, now let me show you another trick. I know this video is going to be a little bit long, but be with me. How do you integrate something like this? Now you have a multiplication of two functions. What can we do? How can we use algebra help here? Because we cannot use a rule right away here, one of the rules that we have learned before. Okay, how can we use algebra help? Well, we can multiply out everything, right? Multiply x by 1 plus 2x. Foil everything. So if you multiply by x, it's x plus 2x square. Can you integrate x plus 2x square? I'm sure you can by now. What can we do? X plus 6 times x minus 7. Foil it. How do you foil it? So x times x, it's x square. X times negative 7 is negative 7x. 6 times x is 6x. 6 times negative 7 is negative 42. Now once you foiled it, you get something that you can integrate, right? You can integrate each term separately. You know how to do that because we have addition subtraction. We cannot do that right away here without foiling because we have multiplication of two functions. Okay, how about question 3 here? We can foil 3 also. Foil in 3 is x minus 2 times x minus 2, right? X minus 2 square. So you can foil this in the similar manner that we did this problem and then integrate the function that you get. Okay, all right, so that's another algebra trick, foil, if you have something like this. All right, so I will see you in the next video where we are going to discuss about definite integral. So if you want to watch this, click on the link that appears in this video and I will see you in the next video. Bye bye and thank you for watching this.